7953.
Hi, I'm William on Team 7953 Vertigo, and here to give a brief overview of the different types of drivetrains and the benefits and drawbacks to each type. The most common type of drivetrain is the tank drive. It places standard wheels on the corners of the robot and has a straightforward approach to driving. The left and right wheels are driven independently in a tank drive. A variation of tank drive is the West Coast and six-wheel drive, where the middle wheels are dropped a quarter inch to allow better turning. The benefits to this type of drivetrain is that it allows good traction and can push other robots around. It is easy to program and it is also easy to drive. On the cons list, the tank drive is not as maneuverable and is a harder time turning and adjusting, so more bulky. Another option for a drivetrain is the types of treads that you use. Restart. Another option for a drivetrain is the tread drivetrain. It is built with a belted tank tread and driven on multiple pulleys. This is great for most terrain and gives the best traction, but on the con side it is very low maneuverability with the FTC approved parts for teams, and the tread drivetrains are very prone to braking. The next option is mechanism wheels. The layout of the wheels is similar to that of the tank drive, but each of the wheels is powered separately, which allows for the horizontal or lateral movement that is so unique to the type of mechanism wheels. This is good because it's not incredibly difficult to design and it has increased agility than the tank drive. But unfortunately this drive lacks a lot of power, and the programming is a little more difficult, and driving is a little more finicky, so it requires more practice. Another type of drivetrain is a holonomic drivetrain. Pros to this drivetrain is that it is highly maneuverable without losing any speed, but it is pretty weak and has a bad time defending against being pushed around. It is also hard to program. The H drivetrain uses omni wheels, but in a tank style orientation, with one omni wheel at the center of the robot placed to allow for sideways movement, similar to the letter H, hence the name. Pros: the H drivetrain is easy to build, and the lateral motions is very valuable to the robot. The problem with this one is that, similarly to the holonomic drivetrain, it loses a lot of power and can be pushed around easily. Lastly, the swerve drivetrain is the most complex, but it can be very powerful when assembled properly. A typical swerve drivetrain is composed of 4 traction wheels. Each wheel is separately powered and rotated in both X and Y directions. The pros to the swerve drivetrain are that there is a very powerful and maneuverable setup, and it also combines the tank and holonomic drivetrains. Unfortunately, this drivetrain is pretty complex to program and build, and it uses a lot of resources that are limited by FTC regulation, like servos and motors. Thank you for watching this video. I hope it helped you learn about the different types of drivetrains. Our team will also be coming out with other videos shortly about the different aspects of programming and other different facets of FTC and robotics competitions in general. Thank you.